So welcome back to the next part of the 200-gallon cylinder reef tank service, as well as calcium reactor installation. You can see the tank is doing relatively well. We could certainly add a whole bunch more corals, but we've had to struggle with calcium and alkalinity, and we've also been dealing with phosphates and nitrates, but I think we've got the latter under control. So with that said, Scott's here and he is eager to get involved in the installation of the reactor. So let's get to work.
Alright, so we're over at the cylinder tank customer's house and we're getting ready to install a calcium reactor on here. This is a Geo, what is this? This is a 612 X2, I believe it is. 6-inch diameter, 12-inch tall, dual chamber calcium reactor, which we're going to have to assemble. We've got our reborn media, we've got our ARM fine media, which will go in the buffering chamber. The reborn will go in the main chamber, and then we've also got the remag media someplace around here, which is a magnesium media that will add the magnesium to it. But the first step is going to be to assemble our Geo here. We've got our pump inside here. Wrap everything up nicely. Jim hasn't brought me the scissors, so I'm going to struggle with this saran wrap here. Thanks, Jim. We'll get this all assembled, get the reactor filled, and then we've got to add some components to the Apex system. Apex is going to need another energy bar for the reactor. We're going to need 3 outlets, one for the CO2 regulator, one for the circulation pump, and then one for the mower feed pump that we're going to use on this. And typically, for the calcium reactor, a lot of people use a manifold or a dedicated feed pump, such as a mag drive or something like that, to feed their calcium reactors, and we're going to use a peristaltic pump, and that way we can eliminate some of the headaches that go with calcium reactors. People that use just regular kind of feed pumps, one of the big issues that you run into is that the feed pumps provide a lot more flow than the calcium reactor needs, and the end result is you end up with having to use a needle valve, and the needle valve has a downside in that the effluent tends to clog up in the calcium reactors. The water that comes out of these reactors is very, very turbid. It's got a lot of calcium in it and stuff, and with needle valves they plug up. So we're going to feed this with a peristaltic type of pump that we can control the flow rates on, and that'll give us much better control over the reactor itself, eliminate the need for a needle valve, and the end result will be that we'll have a very consistent flow rate. We'll have a very consistent pH rate because we're going to use an electronic-based regulator, and that regulator will allow us to really control the bubble rate of the CO2, and the end result will be a much more stable calcium reactor with less futzing, and ultimately it'll be pretty well set it and forget it. So we're going to get this thing assembled, and then the next step will be to install the Apex components. So stay with us as we keep moving forward. So we got our reactor pretty well assembled. If you were not paying attention like I was, and I put the input for the calcium reactor on the wrong bar, but we got that straightened out. It took me a second to realize what I'd done. Needless to say, so this basically will recirculate the water through the calcium reactor. It'll draw in from the top and then recirculate it back into the bottom, so the CO2 is constantly being mixed through there. So we'll just get this thing finished up here. Got a reborn in there. Put some ARM fine into the second reactor. Just upside down so we don't get the media all over the place in there. The fine media has a much greater surface area than larger media does, which is why we're running fine media inside the second reactor. Dump this out of here. Also got to make room for our remag. Alright, so here we've got our remag. This is magnesium supplement, and as the reborn in there breaks down, the remag will also slowly break down and release magnesium into the system. Put that in there. Where it counts. It'll give us a good balance between calcium and magnesium. Magnesium is really important because if your magnesium levels aren't in the right range, you won't be able to maintain proper alkalinity and calcium levels. So that's pretty important. This time we got our remag in there. Put our lids back on. Don't want to over tighten the screws. You also want to tighten them all evenly. Other lid on here. Get our little fitting good and tight here. Channel locks. Can't have any leaks. All right. So now the next thing to do is get the apex part of the system prepared, and then we can go and get the calcium reactor set up. So we're going to need to monitor pH inside the reactor. This is a PM2 module. This will give us an additional pH probe in the system. And that pH probe will go in the top of the calcium reactor and it will monitor the pH inside the reactor. We want to make sure that the water maintains a low pH level so that it's acidic. We're going to target a range of around 6.6 or so. Try to maintain around 6.6 in the reactor and 6.7 someplace in that range, and then we'll just manage the flow through the reactor in order to keep up with the tank's alkalinity needs. So first things first, get some stuff in here mounted up.
To control and monitor the calcium reactor, we need to install a 4-outlet energy bar, which is controlled by the Apex system. These outlets will supply the power for the CO2 regulator, the Comer feed pump, and the calcium reactor circulation pump. And in addition, we need to install a PM1 module, which is the Apex interface for the calcium reactor's pH probe, so that we can monitor the pH inside the calcium reactor itself.
Hello, my name's Jim Stein and I operate Aquarium Design, and I offer aquarium sales, installation, supplies, livestock, and aquarium maintenance in Thousand Oaks, Westlake Village, Agora Hills, Calabasas, and Malibu, California.
I specialize in custom aquariums ranging from freshwater, saltwater fish, living coral reef, and jellyfish display systems. I've been involved professionally and at many levels within the aquarium industry since 1987, and have been in business for myself since 1999. I've worked for many people, and some for over 20 years now. My team can provide you with a unique range of aquarium systems ranging from rectangular in-wall to freestanding cylinders, bow fronts, and custom curved shapes. Additionally, we can offer a variety of aquascapes such as an artificial coral insert, coral skeleton decorations, custom-made branching rock structures, and themed environments such as this Jules Verne version of 20,000 Leagues Under the Sea. With today's technology in energy-efficient DC water pumps and LED lighting, operating costs are much lower. We can automate many of the maintenance features such as water replenishment, water changes, lighting schedule, including moonlight lighting, and even your general daily feedings. I can even install an app on your smartphone that will allow you to monitor, to be notified, to control, and view your aquarium anywhere in the world. If you're looking for something truly unique, give me a call and let's discuss the possibilities of creating your aquatic dream. I'm knowledgeable, insured, and very reliable. My name is Jim Stein, and you can reach me at 805-241-7140. I look forward to helping you achieve your aquatic dream. Geo's Reef, the fabricator of the world-famous Geo-calcium reactor line, has released a new dual-chamber reactor. The CR612X2 is designed for hobbyists concerned with low effluent pH. Geo reactors utilize the bottom-up water flow method to capture free CO2 and draw it back into the circulation pump. This design consumes less gas in the reaction chamber and less gas in the effluent. Not sure which reactor is best for you? Geo provides several different models. Geo reactors are fabricated in the USA. Check out geosreef.com today. Hi, Jim Stein here with Aquarium Design. I sure hope you're enjoying the show. Just a little inside information. When I met with the customer originally to discuss what it was she wanted, she told me she wanted a cylinder tank and she wanted a living coral reef. Well, I knew right away I needed to bring in my friend Condi to help out with that live rock sculpture. The second thing she said to me was, and I want the app on my phone. Well, I knew right there I needed to bring in my friend Scott Leaf and that we were going to be installing the Neptune Systems Apex Aquarium controller. Here's some information on their most updated version.
The design of the outside of the Apex was just as important to us as what we did on the inside. So the new mounting system lets the Apex flip up and you can easily see where all the cables go. It then drops back down to keep stray water from entering the electronics. Underneath are many of the same connectors found on the previous Apex, things like switch inputs and your variable speed ports, and even Aquabus, so all of your existing modules and accessories will work with this Apex. We've also added salinity monitoring as well. And of course, for monitoring the health of your aquarium, there are the connectors for pH, ORP, temperature, and there's even a connector for 12-volt input for power outage situations. So it's actually quite amazing how many things we put into this new Apex to monitor the health of your aquarium and to control everything that you need to control. But what we really did was listen to all of the customer feedback and put some things in there like Wi-Fi. So now you have Wi-Fi if you want to use it, or you can use a wired connection. One touch firmware updates. We now call it the Apex operating system, and with one touch on your mobile device, you can update it. With the Energy Bar 832, you can see how much power each and every device on your aquarium is using. You can then monitor that for a day, make some changes to say your lighting schedule or your temperature, and see how it changes the next day. The Energy Bar 832 has 3 built-in one-link ports. This means you can connect up with one cable our wave pumps, the dose to dose elements in your aquarium, and future products that we'll come out with. On the new Energy Bar, there are indicator lights that show you when each and every outlet is on or off, and they also will blink if you happen to be pulling too much current on any one outlet so that you don't overload a circuit. We know that tens of thousands of aquarists around the world count on the Apex as a critical component to their successful aquariums. This new Apex gives us the platform to continue innovating for our customers so that they can be more successful with less hassle.
Aquarium LED Mounts manufactures revolutionary articulating mounts for the most popular LED fixtures and pendants. Their unique patent-pending design allows for full articulation of the light. You can rotate the fixture 360 degrees while also tilting it in any direction in order to maximize coverage while reducing shadowing and light bleed onto the viewing panels. They are designed to be used in conjunction with canopies, light racks, and light bars, but can also be adapted for use with light mount arms. The kit includes all the hardware needed to attach to your favorite LED fixtures. Aquarium LED Mounts offers articulating mounts for many popular fixtures, such as the GHL Mitra's LX series, Kessel 350, Kessel 360, and AP700 fixtures, as well as Ecotech's Radeon, AI Hydra 52, and AI Soul fixtures. Custom mounting adapters for other fixtures can be produced upon request. For more information, check out aquariumledmounts.com.
Next step is to connect this stuff to the system with our little Aquabus cables. So this is what Neptune refers to as their Aquabus cable. This allows us to add modules. We'll plug one into this old EV4 here. Down here. Plug that into more cable. We'll connect this guy to our energy bar. And just like that, these new devices are connected to the Apex. Last but not least, we got to give this thing power. And since this thing is not going to draw much current, we're going to just route it right over to this open outlet here on the Apex. And now we got everything set up there. Next thing to do will be to make a couple labels. So we're going to have 3 outlets running the reactor. We've got a feed pump, we've got a circulation pump, and we've got a CO2 regulator. Before I start putting labels on, I just want to see what the out AC adapter looks like for our CO2 regulator, which is this thing. So we'll just put that, we'll end up down there at the bottom out of the way.
So while Scott's making labels and working on the Apex, I'm going to go ahead and do an alkalinity and a calcium test so I can have a baseline as to where we're starting from and where we're going to end up going to.
To understand and apply the results of the calcium reactor, we need to know where we're starting from. I'll establish the starting point by using an alkalinity measurement, which will give me that needed baseline.
7.6 degrees of carbonate hardness.
In addition to checking the alkalinity, I also need to check and define the water's calcium level, as the calcium reactor will alter not just the calcium and alkalinity levels, it'll also have an effect on the magnesium level as well as a slight effect on the water's pH. The alkalinity test was done using what is called a colorimeter, but the calcium test is done using a more traditional titration method. Natural seawater is around 400 parts per million of calcium. It has an average alkalinity of approximately 7 and a magnesium level between 1200 and 1300 parts per million.
About 380 degrees or 380 parts per million of calcium. So 7.6 alkalinity and 380 calcium.
All right, so next thing for us to do is to get some water in there. Just use our ARM container, move Jim's little surf out of the way so we can get some water out of here. Jim's kindly overfilled the sump for me so I can steal some water. You'll notice that we've got our pH calibration packets sitting in the sump there. We want those to be the same temperature as the tank water, so when we calibrate our pH probes, the temperature compensation matches.
By adding water to the empty reactor chambers, we can easily get the reactor's circulation pump primed and ready for operation.
Alright, and we got those things pretty full. Put our lids back on.
The reactor chambers are sealed with a lid and O-ring and secured with a series of nylon thumb screws. This allows the chambers to become pressurized and not leak out any of the water or the CO2 gas that we pumped into it.
I'm wondering if it'd be worthy of putting leak detectors over there.
I think it would.
And so I've already got one behind the sump and one down by the water pump or the chiller. Do I have to get another module?
No, the modules support 4 leak detection sensors.
So all I need to do is get the detector or the probe.
Correct.
And even I could install that, huh?
You could install it and I could program it remotely.
Oh, okay. So it requires programming as well.
Yeah, we'll want to create a virtual outlet that says leak calcium reactor, and that way when if for whatever reason that thing starts leaking, you know exactly where the system is leaking. Alright, so we've got our reactors pretty well put together. Our next step will be to drill some holes in the sump for some little 1/4-inch bulkheads. So we're going to feed this in a 1/4-inch, push lock kind of tubing, the stuff you see on RODI filters. Also clear out a little space here for our reef pump. This is the peristaltic pump I mentioned earlier. To come over, they're inexpensive pumps. And if you really want to go high end, we use Cole Palmer Masterflex medical grade peristaltic pumps. That's what I use on my system. Those things are bulletproof, but this is you might call a 10-cent solution to a 25-cent problem. Little feed pump there, you can control the speed of it down to a milliliter a minute. We'll have set probably starting point, since this system's kind of small, we'll probably set it for around 25 milliliters a minute. These pumps are calibratable, but I'm not going to bother calibrating it because really a flow rate through it, how many milliliters a minute it has exactly isn't as critical as the alkalinity is, and we're not, we'll use that number that it has to it as a point of reference if we need to make some minor adjustments, but like I said, it's not all that critical how many milliliters a minute are going through this that I need to worry about calibrating it. Alright, we're going to need some zip ties. We need a little zip ties, Jim? Okay, we're going to need some zip ties so we can shove our 1/4 inch RODI tubing into that thing and we can finish getting this thing set up. Stay tuned.